Hi, I'm Bob Tabor with LearnVisualStudio.net. We've worked our way through the first 4 labs. That brings us to lab number 5, Lifetime Management, Saving and Restoring State. If we take a look at the text, there's not a lot to do per se, but it does a really nice job of explaining the ramifications of the suspending event that's sent from Windows 8 to your app. And I thought it might be a good idea to explicitly talk about the lifetime of an app, what triggers a suspend, a termination, and so on. So let's start by saying that there's a fundamental change in how apps are terminated with the arrival of Windows 8. In previous versions of Windows, the user decided when to terminate an app. You could have multiple apps open at the same time, usually referred to as multitasking, all right, back in the old days. Each application that's currently running will be consuming memory and processor resources. And if you open up enough applications, your computer began to run low on system resources, i.e. memory. And so the system would then try to help you out by caching some stuff from memory onto disk that it doesn't seem like it needs right now. But ultimately, your entire computer would bog down. Now in Windows Store apps, Windows 8, not the user, is in control of when to terminate an app. So each app in Windows 8 and the Windows Store apps will run in full screen unless they're snapped. Let's not talk about that right now. But each app runs full screen, and you decide when you want to switch to another app. And when you begin the second app, that first app will go into a suspended state. And then this process will occur again as you open another Windows Store app and another Windows Store app and so on. And so this process recurs over and over as you open new Windows Store apps. And finally, after enough of apps have been started, the system is under what's called memory pressure. And so when Windows needs more memory, then it decides to begin to terminate apps that were in a suspended state. So it begins to say, I don't need you and don't need you. And it begins to make more room by getting rid of suspended apps. So what if the user then relaunches an app that was in suspended state before it was terminated, but it was in suspended state? Well, then Windows 8 will unsuspend it. Its memory footprint is still intact. The app's threads of execution can begin using the CPU again. It can use the file system again and the network again, and so on. All right, so what exactly do we mean by suspended and resume and terminated and all these terms? Well, when an app is suspended, its memory footprint, so its variables, its threads of execution are not allocated any CPU cycles, and there's no access to the disk or to the network. So when an app resumes, it's coming out of suspended state prior to being terminated. Terminated means that the app has been completely removed from the computer's memory and now has to be relaunched. So the app is not given a notification that it's being terminated. Now the memory footprint can be reclaimed for Windows 8 for optimization or for allocation to a new Windows Store app, but it's cleared out that memory space essentially. So the Grid App template takes care of the initial setup that gives you the basic process lifecycle management features, and you can extend that, and we'll see a few points of extension a little bit later. But if you take a look at our app.xaml, there are 2 events that are defined in the Grid App template. First of all, there is the onLaunched event in line 45, and then there's also this onSuspending event in line about 125. Let's take a look at the onLaunched event. So if you take a look here in line, I think 59, you can see here that we're trying to ascertain the previous execution state of the app prior to being terminated. So as we launch, where did we leave off from last time? That's what this is asking. And so this application execution state can be one of several enumeration values. In fact, in this case, the documentation is our friend. Let's take a look at this application execution state enumeration, and it gives us all the various members and then their descriptions as well. And so you can just bing on Microsoft.com, so site:/Microsoft.com, and then use the term application execution state, all one word, no spaces, and then space enumeration. So for example, if we were looking at this and we might want to understand the difference of not running versus terminated, we could see here the explanation that the app may have been downloaded from the App Store but not executed yet. Okay, makes sense. That's a helpful distinction for me if I ever need it for my particular app. Notice in this case, back in line number 59, we're checking to see if the previous execution state was terminated. And if it was, then we're asking the suspension manager to restore the previous state in an async fashion. All right, so this suspension manager, if we were to go to definition, it's actually created here by the grid app template in our common folder, suspensionmanager.cs. All right, and it takes care of remembering which page of our app the user was working on prior to being suspended, and it saves that information in an XML file called sessionstate.xml. And so we could pop that file open if we could find it on our hard drive, and maybe we could get a little more insight as to what it's actually doing. I actually have, I can show you this much. You can find it on your C drive under users, then whatever your username is. In my case, it's Robert. Under app data, which is a hidden folder that you'll need to show. Local, I think it's under packages, and then you're gonna have to figure out the GUID, and this part's not easy, right? Because you can see there's quite a few apps that utilize this. But in our case, it's gonna be one of these most recent ones that we were just running here, probably this one right here. And then local state, and then there should be a session state.xml. Let's see if there is one here in this other one. Local state, session state.xml. We can open it up with Notepad. All right, and if we wanted to break it apart and learn a little bit more about it, we could. I happen to have one from a previous run that I'm going to paste here into Notepad. So let's just close this because I don't want to make any changes to it. I don't think it would be a good idea to modify any of this. But here's one from a previous run. And so you can see that this is a serialized version of an app frame, okay? And it contains the last pages that we navigated through, along with some other details in navigation history, like the pages we navigated through and the data that's needed to rehydrate those pages. And I find that opening up a file format that's used gives me some clues as to what's going on behind the scenes. And so that's the only reason why I took that little departure there. So the cool thing is this, in this suspension manager, that we can see here the save async method and the restore async method, and we could easily extend these methods to store our own and retrieve our own application data. And so as the lab points out, that's not really necessary for this app, our Contoso Cookbook, because there's no real state that's worth saving, you know, besides the last page that the user was working on prior to the suspension event. Okay, so here's what I'm going to do just to show how this works. Let's go ahead and create a new project. It's going to be a grid app. We're going to call it app 1. Just take all the defaults. And I'm going to go to the item detail page, and I'm going to rip it to shreds. In fact, I'm going to just yank out everything out of here. I'm just going to take the flip view and just get rid of it completely. And everything that belongs to it. Gone. All right, so, but what I am going to put in its place is a, I'm just going to put in a text block, or I'm sorry, a text box. We're going to call this a stateful text box. And I think we're going to have to make some changes here. I'm going to put it into grid.row equals 1. Then I'm going to make its height something reasonable, like, I don't know, 45. Then I'm going to, you can't see it in the little designer area. So that's because it is in the center. So I'm going to put its vertical alignment equal to top, and I'm going to make its width something reasonable, like, I don't know, 400. And then I'm going to horizontal align it to the left. All right, that feels good. All right, so there we go. That's good. And so now we're going to go into the item detail page.xaml, and the good news is that we've already got a template of how to make this all work. I'm going to get rid of all these flip view references here, like that and like that. But the good news is that we've already got an example of how to retrieve information from the page state here in this example. So we're just going to use that little template, and first of all, let us retrieve the state by going if page state is not equal to null, and the page state contains a key that's called stateful, whatever we called that. Here, let me just put it on the clipboard because I'm going to need it a couple times here. Yeah, stateful text box. So if that is true, then what we're going to do is retrieve out, or actually set stateful text box's text attribute equal to the page state, getting into the stateful text box key, and then we'll toString it because it's an object when it comes out of there. All right, great. Now that's half of the equation. We also need to then save the state before terminating. And so to do that, we're going to modify the let's go and get rid of that. We're going to modify the save state method, and so it's going to look something like this. So page state stateful text box equals stateful text box dot text. All right, great. So now let's go ahead and save those changes, and then we're going to run the app. And we're going to navigate into a page, and now I'm just going to type something, literally. Check on sports, we'll check on news. And then we'll come back to into our app. All right, and we can see something is still there. So now let's do this. Let's go to the desktop, and we're going to suspend and terminate the app. And now we're going to rerun the app. And you can see something is still there. Great. All right, so keep in mind that our app has about 5 seconds to do its work once it receives the suspending event. During that 5-second window, the user could hop out to an email for a quick check and then back to your app, so no real work would be necessary. The app would just continue on as if nothing had happened, since it never really officially suspended, and whatever work it did when it received the suspending event shouldn't be harmful to the app in any way. So no harm, no foul. So finally, with regards to our app, there's one other extension point that makes sense for us to consider depending on our app. Back in... Let's go back to our app.xaml.cs. If you were to take a look at the constructor, we see this, we're wiring up a suspending event. We could also do something like this if we wanted to. We could check for the resuming and then create an on resuming method if we wanted to. I guess we don't need to do that. And then implement that if we wanted to, that event handler, all right? Like so. So, and that would handle the process of resuming if we wanted to take control of it. So this would allow us to refresh the data in our app if we were pulling from a web service to get the most recent information. And so the canonical example is that of a weather report, or a news headline, or a stock ticker, or sports scores, the latest messages, from a user, maybe in a chat room, or updates from other players in the game that you're building, and so forth. All right, so finally, one last topic I want to discuss that's tangentially related here. You might wonder about code running in the background. So can I have an app that's running in the background even though it's not a full screen app currently running in Windows 8? Well, yes, there's actually a way to run code in the background by creating a background task, which is a separate DLL that's managed outside of the app. Now, mind you, it must be referenced by an app. However, after it's been launched, it can run whether or not the main app is running. You would create a Windows app class library that contains a class that implements iBackgroundTask, which again is just a contract to implement a run method. And so then you have to create a reference to the class library DLL from the main app and then add a declaration in the package.appx manifests designer that you want to use this as a background task, or you want to have access to a background task. Now that the class library DLL task is waiting to be triggered, it can be triggered by one or more task types like audio or a control channel or system event or a timer or a push notification. Any of those could then spring your background task into action. And you know what, at this point I'm really getting a little bit over my own head here. What I'd recommend is this. Take a look at this web page and it'll explain everything you need to know about running background tasks from your app. So just do a search on site:/microsoft.com supporting your app with background tasks, and it should bring you to this page. All right, so in this lesson we learned more about how Windows 8 manages the lifetime of our app's processes. We learned about the Grid App Suspension Manager and how it takes care of the details of serializing our app's navigation state, and we saw how to extend that to form data like our little text box or other variables that would be required for our app to run. We saw how to further extend the app by adding an event handler for the resume event, and how to run background tasks in an nproc server DLL that responds to external trigger events. All right, so that finishes up lab number 5. I trust that you'll read the additional text in that lab and to get additional insights, and we'll pick it back up in lab number 6. We'll see you there. Thank you.